Hi everybody. In class we didn't get to some of the different types of inheritance that you'll be needing to do your problems. And so I think we left off on this one, pleiotropy. So let's keep going and I'll teach you about the last two, okay? And so let me get my pointer here. All right. So the next one is epistasis, and this one's sort of like pleiotropy. So you'll see that there's black labs, yellow labs, and chocolate labs. And so it turns out that there are basically two different alleles that control this. Now, the big B is for black. Okay, little b is for brown. All right, but there's another allele that affects hair color. Okay, so this is kind of the phenotype that you see, but there's two genes that control that phenotype. And so another one is called E. And if you inherit the dominant E allele, you have normal pigmentation. Meaning that if you inherit, two big B alleles, you would be black, and that pigment would normally deposit into the fur. Now, if you end up inheriting the recessive little e, then what happens is no matter what you are, black or brown, whatever gene you inherit, whatever allele you inherited, it doesn't matter what it is because you don't have normal pigmentation. So that dog would be a yellow lab. It doesn't have any color. It's almost like a bit of an albino if you want to think of it that way. Okay, so no pigment deposition. Okay, so let's look at these two parents that are mating. And, oh shoot, it won't let me write over there. So I'm just going to recopy that over here. Okay, now this dog right here, black is dominant over this brown. So this is going to be a black dog. And it's going to have normal pigmentation, so it will look black. This dog, you'll see it inherited a brown fur color, but it doesn't have any pigment deposition. So this dog is going to be yellow. Okay, so we're going to take a black lab and a yellow lab and mate them and see what happens, okay? So now we're going to do, this is going to be a bigger Punnett square, kind of those special ones. So we're going to have to look at both of these traits together. All right, so each dog is going to give off a B and an E. So this dog could either give off big B, big E, big B, little e, something like that, or little, little, right? So these are the possibilities. Okay, now this dog right here only has one possibility. So let's put this together. So big B, little b. Okay, now let's take a look. So this offspring is going to be black and normal deposition, so it'll just be a black dog. This one, look, it doesn't matter what any of this is because it's little e, so no pigment, so this one's going to be yellow. This one looks like it's supposed to be brown and it has normal pigmentation, so this one will be brown. Okay. Little, so that means, well, doesn't matter what's going on over here, they are little e, so this is going to be a yellow lab. All right, so the phenotypic ratios is actually 2 to 1 to 1. So this is yellow to black to brown. Okay, so that's epistasis. All right, so it's basically two alleles that are related like this. Okay, now another one that people often wonder about is skin color. We know that generally speaking, if a very light-colored person has children with a very dark-colored person, then it's likely that the kids will be something in between. But once in a while, you get two people where the children, it's not quite what you would expect. So let's take a look at the odds of what would happen if these two kind of hybrid people, so medium colored skin people mate, you can see that there's 3 alleles in here. So there's many genes that affect this. But each of them sort of have an equal play. So you can see that it really matters how many of these dominant alleles or these pigmentation alleles that you get. All right, so you can see that if you have all uppercase, you have all the slots filled in. All right, and if you have all lowercase, you are basically an albino, or you're just very, very pale. Okay, so you can see if 2 very, very pale people get together, then they're going to have a pale kid probably. But a lot of people are somewhere in between, and so the offspring could be a number of these different types of pigmentation. All right, so it's possible that 2 medium skin tone people could give birth to a kid that's very, very dark. The odds are pretty small, but it is possible, and same goes, they could have a very, very light-skinned child. And so you could see how that plays out in this large Punnett square. You would never have to fill out a Punnett square like this for polygenic inheritance, but you could be shown a graph like this, or just be asked a question about kind of how it works, okay? Hope that helps. Talk to you guys next class. Have a good weekend.